and welcome to my senior project presentation video. My name is Sofia, and today we'll be discussing how neurological differences between genders affect sexism and how to stop it. Before we take a look at what it looks like today, I believe we should go back to its origin and figure out how it started. Science has always played an important part in our reasoning and behavior since it gained its popularity during the Enlightenment in the 18th century. However, it wasn't always so accurate as it is today. Those scientists researched the human brain at some point and presented their findings to the world, who took them as fact. These same facts stuck, and a few, maybe 100 years later, they remain so. Now, how does this affect us? And what's the big deal? Why do people care about it? Well, you can take the conclusions the scientists presented and think of it as a seed, which, over the years, after not being cut or replaced, sprouted into a big influential tree we could call sexism. This same tree was watered with misconceptions that essentially revolved around one thing. The differences between the male and the female brain contribute to the roles that have been assigned to them by biology. And by biology, I mean the roles that early humans lived in order to survive, when the latest technology was a rock axe and not the new iPhone. After I did some research, I found two of the main myths regarding the neurological differences between males and females, and decided to research even more to see if they were based on misinterpretation like I previously thought. Let's start with myth number 1. Women are only good at certain fields and men are only good at others. This one is a popular one I grew up hearing throughout my entire life, so I was eager to see the extent of its truth, and found it correlated to two different brain characteristics: neural connectivity and brain matter. Neural connectivity relies on the way the brain is wired to function. It could occur either laterally, from side to side, or linearly, front to back. Each of them possesses distinctive traits, as was explained by Penn Medicine News, the online journal for the University of Pennsylvania's Medicine Department, based on a study conducted by Regina Verma, PhD. Lateral connectivity facilitates communication between the analytical and the intuition, multitasking, and creating solutions for a group, while linear connections facilitates perception, coordinated action, and makes them better at learning and performing a single task at hand. Ian Grant, assistant professor of behavioral neurology at Northwestern University, revealed that linear connections might also result in heightened perception and stronger motor skills, and lateral ones meant more intuitive thinking, analyzing, and drawing of conclusions. Out of the two, women were found to have lateral connections and men linear ones, which meant that the aforementioned skills are facilitated towards those certain groups, facilitator being a key word. Both Grant and Penn Medicine News conclude that the skills are not a predetermination to each gender and merely presents a higher affinity. So, lateral and linear connections being the cause for certain skill sets, we could scratch that out. Now let's move on to brain matter. As Rory J. McKenzie, writer for Technology Networks, explained, there exist two types of brain matter, gray and white. Gray matter consists of neuronal cell bodies in the synapse where all connections pass through, and is responsible for muscular and sensory activity. White matter, on the other hand, is composed of myelinated axons, which connect the different parts of gray matter and allows the reactions to occur at a much faster rate. It was discovered that while women produced more gray matter, they used white matter the most, and men were found to use gray matter the most. According to Grant, this increases women's likelihood of excelling at language and multitasking and gives men an advantage at task-focused projects. Martin Lutzen, neuroscientist who conducted a study regarding the amount of matter in adult brains, presented these brain scans representing the amount that actually differed between the genders, the orange representing where women have more gray matter and the blue where men have more white matter. The study revealed that there is considerable overlap between the features of brain from males and females and that these features are internally inconsistent, essentially concluding that although sex can be deduced by looking at a brain, these same characteristics don't inherently prove cognitive differences and don't establish that the traits associated with each type of matter are absolutely true to each gender. This aspect of the brain does raise some questions regarding the myth, although it is neither an absolute rejection nor a confirmation. Overall, both characteristics were found to be more suggestions than anything, and does not determine the skill set of a person of each gender, even though it does explain a higher propensity for certain areas and establishes differences within the brain of each gender. Now, moving on to myth number 2, that men have bigger brains than women and therefore are smarter. It is widely known that the male brain is 10% larger than the female's, and that is true, as confirmed by Ian Grant. However, when people read that, they immediately correlate it to cognitive ability and assume it means men are the smarter gender. That is not the case. It was proven and explained by Grant that brain size does not correlate to cognitive capacities, and thus women are not necessarily less smart than men just because of the size of their brain. There might be another influencing factor that is not always taken into account, and that is brain volume. Different areas of the brain have different volumes, and it's possible to be distinguishable by gender. Stuart Ritchie's study, as explained by Michael Price, a Johns Hopkins alumni and writer, discovered that there were 14 regions where men had higher brain volume and 10 where women did. Although there was speculation related to its side effects, Ricci asserted that these differences did not establish affected cognitive behavior and had no effect on intelligence. Rather, he concluded these differences were way too minute and found the brains to be more similar than different regarding brain volume, hinting at the possibility that there should be other factors that do affect cognitive behavior. I myself thought the same thing, as I had gone through neural connectivity, brain matter size, and volume, and found no definitive answer or explanation, other than the fact that these myths were based on half truths that are still being treated as fact. After this, I decided to read more into environmental rather than neurological factors and find how they could relate to these myths that possess such weight in our society. In doing so, I stumbled upon the Pygmalion effect, or the Rosenthal effect. Named after Robert Rosenthal, who led the study along with Leonard Jacobson, the Pygmalion effect explains how the environment of one's upbringing directly affects the way they perform in certain areas or tasks. The study was done in a classroom and consisted of giving a list to the teachers of the scores of a progress test done by the students at the beginning of the year. However, this list was tampered with and the scores of some students were changed, where high-scoring students were at the bottom with low scores, and vice versa. At the end of the year, another progress test was made and it was found that the higher-scoring students were not those in the original untampered list, but rather the high-scoring ones in the tampered one. Some previously low-scoring students were now found in the top, and previously high-scoring ones were found at the bottom. Rosenthal and Jacobson explained this was due to the behavior of those around them. The teachers gave better and more attention to the students they believed had a higher chance of scoring well, providing more opportunities and sometimes turning a low-score student into a top one while ignoring the rest. They deemed it a self-fulfilling prophecy, where what others think of you will become reality. Russell McLean hosted a TED Talk on a similar matter, where he explained the term stereotype threat. He explains how, if you're a part of a group about which there's a negative stereotype, it affects how you think and how you behave. It becomes a subconscious reaction that makes you think differently of yourself and thus makes you act according to what others say you are. This is relevant for young kids in rough neighborhoods pressured to join into gangs, but also to women in the workplace. As soon as I read about this, I thought it was very relevant to the two myths I had previously mentioned. It is likely that women might be worse at certain fields than men, or might be considered less smart, but not because of the way their brain is wired, but rather because of how society treats them. They grew up hearing you're no good at science, women are bad at math, women are the stupid gender, and although not all, most tend to end up subconsciously believing it. Catherine L. Bauscher, assistant professor of psychology at the University of Indianapolis, conducted a study to test this same theory inside the field of mathematics, a predominantly male-considered field. She took 150 men and women and gave them a math test, but before starting, she said it was to see how worse women scored. Women reported feeling very nervous, while the men felt no anxiety levels. The women ended up scoring worse. Although this does support my theory, I believed it led some margin of error, as it was possible these women were just actually worse than men, so I decided to do a follow-up. McLean himself discussed another study, where women in the field of mathematics are giving a test and told its purpose is to show the difference in skills in math between men and women. These women, who are skilled mathematics and graduate students with experience, scored lower than capable, just like the ones in Bauscher's study did. So, if you apply this same logic to other fields or areas where women are targeted, it's logical to assume those stereotypes have the same effect there as it did in mathematics. Okay, so far, we have established that there are neurological differences between the genders that imply a natural affluence in certain subjects for each, but that it's not the reason women are at a disadvantage in the workplace. Rather, it can be attributed to environmental factors that circle back to the stereotype-based myths we established at the beginning concerning women's cognitive abilities. Essentially, how the existence of these myths that have provided the foundations for modern-day sexism is also the main reason people believe them to be true. It has created a cycle that has been difficult to break for many years. So how can we help break it? Russell McLean suggests implementing a growth mindset, to view the brain as elastic and capable of growing and improving instead of limiting yourself to the restraints society has imposed on you. However, this doesn't work for everyone. Since this is something deeply ingrained into your subconscious, it's not so easy to get rid of, or even know it's there. Women in Bauscher's study thought they believed themselves to be capable, but once they were introduced to the idea they might fail, that idea did not survive long, and they did poorly on their test, just like they thought they were expected to. So, let's go back to the tree metaphor introduced at the beginning and think, how do you get rid of a tree? The answer is very simple. You cut it through its roots, so it has no chance of growing back. And if we think of this problem as a tree, we could apply the same logic. By eradicating this problem through its roots, getting rid of some of the stereotypes that are causing this effect, or by debunking myths and permanently changing the mindset of people through education, not only women, but other targeted groups in any field can perform to their best abilities and have equal levels of access to benefits and opportunities in society. It's a simple process that requires a lot of work, but by creating awareness, it becomes easier by the day.